Hi there. Are you ready to fully understand back titrations? I hope you are because it's not too difficult. And I'm going to start with a very simple example. Then let's see if we can apply it to like an 8-mark question. Are you ready? So, well, first of all, it's important that you have clear what titrations are. Okay, so that's a bit specifically for the calculations of back titration, including actually redox, because very often in redox titration you either have like a linear titration or a type of back titration. So that's where it gets a bit more complicated. But I want you to fully understand back titrations with me today. So look at this example. This is the example that made me really click years ago, thanks to IB chemistry notes. um, how to do the calculations with back titrations. So you walk in the shop with the coins worth €8. You walk out of the shop with €430. You bought a rubber duck. How much was this rubber duck? Was the difference between them. So you had initial money. You calculate how much money you spent, or guess what? How much are left over. That's what I mean, how much are left over. And you can find the amount that initially you used up. So can you link it to a chemical reaction? In a back titration, normally you have an initial reaction, something that you know, something that you don't have. So you find your initial amount. Let me make some notes that then we will carry along in the next slide. We have an initial amount. Let's call it mole and not money, because we know that we do calculations with mole. Change received, you have a final moles. Cost of the item, moles used. And you guess how you find the moles used? You have your initial minus the final. So the final mole, what I mean is that from the initial reaction, and these initial moles would be a certain A reacting with B to form a C. And very often it's, for example, like a specific compound or a metal or something that you don't know and you can't find directly. That's why you need to do this reaction. And you don't know something about B, maybe the amount, maybe the type of metal, but you know everything about A. So you have A in like a big amount so that it reacts with B. But then some of this lay that is left over will be reacted with something else, maybe in a titration. Yeah, to find. So this would be the amount in excess from the reaction above. So if you find the amount in excess and the initial amount, you can find the amount that was used. And very often you have to work out the ratio from this initial one. So that's just first overview, just all theoretical. Let's follow it along in an actual example. This is the question that I would like to go through with you. Stop the video, read it, and when you're ready and you feel like you've understood the reactions, you've understood what's reacting with what and how this could be a back titration, play. So when we start, first of all, this is a 5-mark question. It's from OCR paper 2020, and it's a back titration. And I know, because I see different step, I know that an initial amount has reacted, and then there is another reaction taking place, and a titration, redox actually, and we have to find an unknown amount. Those are all hints to understand that is a back titration. 3 steps to always keep in mind. You have some kind of initial amount. You will be able to find at the very end, so probably starting from the bottom of the text, you will be able to find the amount in excess, so the moles in excess, to find the amount that they reacted at the beginning, so that you can find the mass or the moles or the percentage or whatever. So keeping these 3 steps in mind, let's go ahead. The first thing we can find, well, I will always tell you the back titration starts from the back. We have a titration, we have the potassium permanganate, we have a volume and the concentration. So that's the moles that we can find. So the moles of this MnO4 minus, always use the labels, it's very important to follow along, would be the concentration 0.01 times the volume 12.6, obviously divided by 1,000, because it's in decimeters cube. Always keep an eye on the units if you need. So this gives us 1.26 times to the minus 4. And as I always say, things to keep in mind is mole ratio moles. What's the ratio that we want that we're interested in between the permanganate and the SO3 2 minus, because that's what is reacting along. So the ratio is 2 to 5. Okay, and this is the challenging thing normally about redox titration. Okay, there are normally complex equations with the big ratios, or well, something that we have to work out. In fact, we can find the amount of SO3 by doing 1.26 times 10 to the minus 4 times the reverse fraction 5 over 2, therefore equal to 3.14 times 10 to the minus 3.15 times 10 to the minus 4. Ask yourself always, get used to it, in which volume is in 25 centimeters cubed. That's why as you do one calculation, keep an eye on the text, yeah, because here, look, this is really important, 25, 250. So we can find the moles of SO3 2 minus in 250. Looking at the dilution factor, it would be times by 10. So this times by 10 will be 3.15 times by 10 to the minus 3. This is our moles of the SO3. But this is the SO3, yeah, that the moles that we have, okay? So we need to now find what we had at the beginning. At the beginning we had, so this is the amount that is in the solution. Yeah, and at the beginning we have 525 grams. We need to find the percentage of that. So having found that, we go back to the beginning and we can already actually find the mass. So let's do the mass that corresponds to this SO3, so the actual mass calculated from the titration. So this is a bit more actually redox titration than back, but would still follow the same steps. So it would be 3.15 times 10 to the minus 3 times by the MR, which is 126.1. This gives us 0.397. So now we're able to find the mass of this Na2SO3 that was present in 1 kilo of meat. So think about that, we need to do it in 1 kilo, okay, because now this is the amount of iron, okay, so let's think about that's the mass, and we had 525 grams, okay, so we need to get that in 1 kilo, okay, so the equation that we will do would be the mass that we had, grams, and then divided by the amount that we had at the beginning, 525. But this would be kind of the percentage by mass, but then of course we want it in a kilo, so we times it by 1,000. Okay, so percentage, so the fraction of the mass, and then times by 1,000 to get it into kilo. So we get 0.7566 grams. Because the question here was in milligrams, we need to compare it also in milligrams. So we times that by 1,000, so another 1,000, and that would be equal to 756 times 0.6 milligrams. So it is, so we need to make a conclusion. This is specific for the question. So yes, we can say it's actually less than the maximum permitted. Okay, so those are the steps. There is at the end only one titration involved. There are some back titrations that you have two steps that you have to follow. Anyway, a lot of things to consider in titration. So first, understand what is happening so that you understand which steps you need to take and how the equations are related. So in this case, we had one solution. We could find what was in that solution from the titration, and then whatever wasn't reacted, we can go back and then find, in this case, was like an amount in milligrams. Okay, so keep in mind that these steps, and always think about the ratios, the correct conversions, because it's a titration, and dilutions, because I think in all the question I see that is 250 the initial solution, and then you only titrate 25. So keep that in mind. I hope this is helpful, and if you want a worksheet that I would personally correct, just comment below and I will send it over with the solutions. Okay, I hope this is helpful, and I'll see you in the next video.